Misrepresentations of data. Lesson objective: describe what can make a graph misleading or deceptive. Let's start with a quote. Statistics, the only science that enables different experts using the same figures to draw different conclusions. Now this sort of sets the tone for this section. We're going to be looking at how graphs contain or display the same information, but the viewer may draw different conclusions. Okay, let's begin with the vertical axis. Here is an ad from Chevy trucks. The claim is more than 98% of all trucks sold in the last 10 years are still on the road. And we have a bar chart here. Here's Chevy, Ford, Toyota, and this is Nissan. And what we see from this graph is that Chevy appears to be the best. But if we really look at the scaling, we see that this starts at 95%. So this difference here and here and here is exaggerated, because this is not starting at 0, this is starting at 95%. So this would be 98%. They're a little bit more than 98, and Ford is a little bit more than 97. So we're talking about a percent difference, and it appears from the chart that it's more than 8%. Let's look at another example. The data in the table to the right represents the historical life expectancy in years of residents of the United States. So in 1950, the life expectancy was 68.2 years. And we can see as the years go up, the life expectancy goes up. So we're first going to construct a misleading time series graph that implies life expectancy has risen sharply. And then we're going to construct a time series graph that is not misleading. Let's look at the first one. 1950, it was 68.2, and we can see that it's increased every decade beyond that, and this graph just displayed the data from the table. However, again, we start at 68. We can see that when the vertical axis is started at 0, these differences really don't look as dramatic as before. So anytime that you're viewing a graph where it's been truncated, where it does not start at 0, you should be aware that the differences may be exaggerated. Here's another example. This is personal income per capita for 2 states, California and Nevada. Now, when we start at 0, the differences are not exaggerated. If we started at 30,000, the differences would be exaggerated. To correctly interpret a graph, you must analyze the numerical information in the graph, so you will not be misled by the shape of the graph. Let's look at some pictographs. Okay, in this bar chart we see the comparison of the United States to Japan in daily oil consumption. We see that the vertical axis is starting at 0, United States is 20, Japan is 5.4. So the United States is about a little bit less than 4 times the consumption of Japan. Now, if we look at this three-dimensional graph, which is cylinder, probably to represent oil barrels, the height is correct, same as the bar chart, but the problem is now the United States is more than 4 times larger than Japan. The United States is actually about 16 times that of Japan. So if you were to take this little can, how many of these little cans would fit in this larger can? And it's a lot more than 4. If this height is 4 times larger, pictograph will also expand the horizontal scale 4 times larger. So it's actually 4 times 4, which is 16. So this barrel is 16 times larger than this barrel. The proportion of the difference is not correct. This is misleading. Okay, here's another example of a pictograph. These are the people who died in the Titanic. There were 325 in first class, 285 in second, 706 in the third, and the crew was 885. Now, the reason why this graph here is misleading is because instead of using just a bar chart, they use this picture of Titanic boat. So as you increase horizontal scale, the vertical scale is also going to be increased by that amount. And the problem is we're looking at area, and area is 2 dimensions, and this is not a fair diagram of the difference. Okay, let's look at some pie charts. And now, while some people may like the 3-dimensional pie chart on the left, on the correct pie chart to use would be the two-dimensional that's on the right. And the reason why is whatever slice is shown to the viewer, this looks larger than what it actually really is. Well, let's look at an example. The National Survey of Student Engagement is a survey that, among other things, asks first-year students at liberal arts colleges how much time do they spend preparing for class each week. Here's the results from 2007. 0 hours had a relative frequency of 0. 1 to 5 is about 13%. 6 to 10 is 25%, so on and so forth. If we were to take this data and make a display that exaggerates the percentage of students who spend between 6 and 10 hours, we can do that by a three-dimensional pie chart and put that section, 6 to 10 hours, in front. And then to make a fair comparison, we're just going to do a normal pie chart that's not misleading. So as we can see, this section is first, and it appears to the reader to be the largest section, and that's from 6 to 10. Now if we look at it this way, we see that the section is not exaggerated. It is a big section, but it's not as large as the three-dimensional pie chart. Here's another example of something that could go wrong with the pie chart. It appears that this is 50%, but according to the pie chart, it looks like it's less than 50%. We have to keep it honest. Make sure your display shows what the data is saying. Here's another example. What's wrong with this one? This sort of implies that this is a pie chart, but the problem with this graph is these percentages do not add up to 100%. They're more. This is a misleading display. So let's look at some guidelines for constructing good graphics. Title and label the graphic axes clearly, providing explanations if needed. Include the units of measurement and a source whenever appropriate. Avoid distortion. Never lie about the data. Minimize the amount of white space in the graph. Use the available space to let the data stand out. If the scales are truncated, be sure to clearly indicate this to the reader. Avoid clutter, such as excessive grid lines and unnecessary backgrounds or pictures. Don't distract the reader. Avoid three dimensions. Three-dimensional charts may look nice, but they distract the reader and often lead to misrepresentations of the graphic. Do not use more than one design in the same graphic. Sometimes graphs use a different design in one portion of the graph to draw attention to that area. Don't force the reader to any specific part of the graph. Let the data speak for themselves. Avoid irrelative graphs that are devoid of data or scales. Thanks for watching.